We are now a domestic wastewater treatment plant in Parakar community of Armenia region, which was constructed within the framework of the GEF Small Grants Program and Water, Climate and Development Program in Central Asia and Caucasus regional project. The project was funded by GEF and the Department of International Development (DFID) of the UK and co-founded by the community. None of the 20 wastewater treatment plants existing in the past operates today. The only plant that operates to some extent is the treatment plant of Yerevan, which performs mechanical treatment. The remaining 19 plants have stopped operating a long time ago, and they are in a state that it is senseless even to speak about their rehabilitation. The only solution is building new plants. Today, we already have 5 treatment plants that implement only mechanical treatment. Besides, we already have the first biological treatment plant in Armenia, in Parakar community, which has been designed and built with application of alternative technology, applying a hybrid solution of the technology close to natural treatment systems. Domestic wastewater treatment allows treating of wastewater, preventing filling of untreated wastewater into the village area and irrigation system, reducing the epidemic risk, improve the sanitary condition of the village, restoring degraded agricultural land of the community, and having 11.7 liters per second additional irrigation water. The lack of finance is a major obstacle to implementation of this kind of work, but I think if desired, it can be overcome. It could be possible to miss some other not so important activities and channel the finances to this more important program. From 1993-1994 to 2010, 2 villages were completely covered by wastewater, and it was an urgent need for us to build this treatment plant, because it was a big problem to remove wastewater from both villages to the irrigation system throughout the year, which in its turn could cause a variety of diseases. Besides, it was also dangerous that some segments of the community water supply and wastewater pipes were parallel, and during the emergencies it was possible that wastewater could penetrate into the drinking water system. And we began to collect money as much as we could and from where we could, and direct the funds to the project implementation. The pilot project in Parakar was developed by Country Water Partnership still in 2010. Given the limited funding within the framework of this project, the pilot project was divided into 2 stages. The first stage was implemented in 2010-2012 and the second stage in 2013-2014. In fact, today, we have reached the final stage of construction of the Parakar treatment plant, and after the National Conference on Municipal Wastewater Treatment Alternative Technologies, we invited the participants to show what had been done within the framework of the pilot project. The implementation of the second phase began in April of this year within the framework of the regional project on water, climate and development in the Caucasus and Central Asia. In the second phase, the secondary clarifier for sludge settling, the aerated reservoir of the settled flow, sludge bed, as well as naturally aerated lagoon were constructed. The latter has a small depth, and secondary treatment is carried out here through aquatic plants. The design of the treatment plant was developed by Ginge Engineering and Consulting Company, thanks to which it became possible to use a relatively cheap and effective alternative wastewater treatment technology for the first time in Armenia. We have organized the works primarily with Ginge Consulting Engineering Company and the Country Water Partnership NGO. I would like to thank Mr. Mesropan and Mrs. Aravik for their support in the implementation of the second phase of the project. Otherwise, we would have to wait another 2 years until the money was collected and the second phase implemented. But thanks to them, today we already have such a beautiful complex. The project's main concept was consideration of the wastewater as a valuable water resource and the treated wastewater reuse for other purposes. Development and operation of decentralized domestic wastewater system. Introduction of a new, relatively cheap, in terms of construction and operation, wastewater treatment technology. Identification of opportunities for duplication of the project. Look, today we apply this method in Paracar, which is tailored to the size of the allotted land plot and the qualitative composition of the wastewater and other parameters. For big cities, probably, application of this technology is not advisable. For big cities, conventional treatment plants are to be constructed. For small communities and small facilities, compact treatment plants may be proposed. For example, for treatment of household wastewater of Tahut Mining Enterprise, GINT has installed 3 prefabricated small compact plants. Paracar is one of the leading communities of the region. It has 2,500 households, about 10,000 population and developed infrastructure. 60% of the community is connected to sewage network. The population has privatized agricultural lands, the major part of which were not tilled and was exposed to degradation from year to year, mainly because of pollution of irrigation water by domestic wastewater. The village wastewater was removed through a sewage system to the idle pumping station in the center of the village. After, it was filled into the adjacent area and into the irrigation canal and then flowed through the village, through the schoolyard and residents' backyards, up to the southeastern border of the village. For many years, the irrigation canal had been almost fully filled with sediments from wastewater. The latter often flowed out the canal to adjacent areas, making foul odor and anti-sanitary condition. Today, I can proudly say that this was a boom for us. We finished the construction works and we are adjusting the plant operation. I hope that the treated wastewater will be usable for agricultural irrigation. Looking around, we see that people started to cultivate their land in this area. Now they grow alfalfa, but in the future, fruit trees will grow here, as it used to be in the past. People already have the desire to cultivate land because irrigation water did not reach here in the past, but today there is no problem. 3 years ago, it was not possible to open the windows in houses and at the school because the stench was everywhere. The irrigation system was filled with wastewater. Wastewater flooded freely in the community streets. Today, as a result of repair works and reconstruction of the wastewater system, wastewater is entirely removed to the treatment plant, and after the corresponding treatment, here it can be filled into the irrigation system. The first stage of the project was implemented with GEF funding and the second stage with the Department for International Development of the UK funding. In both cases, the community had significant input. The following facilities were constructed as a result of the project implementation. Wastewater collector from the settlement to the plant, screen, pump station, air blowing node, biological lagoon with artificial aeration, sedimentation lagoon, biological lagoon with natural aeration, sludge bed and other auxiliary structures. After the first stage of the project implementation in 2012, the results of monitoring showed that as a result of the treatment, the wastewater BOD and COD values were reduced by 60% and the suspended solids by 85%. Of course, one thing is when we talk during seminars or meetings, and it is completely another thing when people can see themselves the actually operating plan that simultaneously solves several problems for the community. It not only provides the appropriate sanitary condition of the community, but also creates additional irrigation water amount. This plant can simultaneously act as an experimental plant and can be useful for teaching and training the specialists. And of course, it is encouraging that in the opinion of the specialists of ministries and regional governments, this exemplary experience can serve as an example for replication of this experience. The entire lagoon system, constructed in the second stage of the project, is divided into 8 sections, with hyacinth and non-hyacinth sections following each other. The aim is to provide natural wastewater aeration. The advantage of such a system is that not only the value of biological oxygen demand is reduced to 30-35 milligrams per liter as a result of the treatment, but also disinfecting of wastewater takes place at the expense of bacteriological processes taking place in the hyacinth systems. As a result, the Coley index reduces about 4 times. As a result of the project implementation, the degradation of agricultural land is prevented, degraded land area is reduced. The sanitary condition of the community is improved, the risk of epidemic outbreaks is reduced. The community has its own domestic wastewater treatment plant and its decentralized management system. At the expense of the treated wastewater, 11.7 liter per second additional fixed amount of water for irrigation is available, which is not dependent on weather conditions and climate change effects. Opportunities to develop additional agricultural land and to obtain additional income are created. The recycled sludge is used as cheap and good quality organic fertilizer to fertilize gardens and to get environmentally friendly products. The contamination of agricultural lands with wastewater is prevented and population food security is ensured. Favorable conditions are created for integrated management and reuse of water resources of the community.
As after the first phase, now too I hope that the next year we will be able to improve and beautify the area of the treatment plant. It seems we can succeed this because we have additional money for this purpose. The advantage of using such technology is that the capital and operating costs are significantly lower. The cost of rehabilitation of the wastewater system of Parakar, according to the general plan of the community, was estimated at $1.5 million. The total cost of the treatment plant constructed under this project, which provides not only wastewater disposal, but also its treatment and further reuse for other purpose, is $260,000 equivalent. Such treatment plants provide low prime cost of wastewater treatment, 5 US cents for treatment of 1 cubic meter of wastewater, at the expense of the treatment technology and not highly skilled operating personnel. The project results have been presented at national, regional and international level during workshops, seminars and conferences. We believe that the dissemination of information in such a way will allow duplicating this experience of domestic wastewater treatment as a positive example, both in Armenia as well as in other areas, especially that Armenia's government began to pay attention to the rehabilitation of the wastewater treatment process.